Kinematics of rigid body. Part number 3. Translation of rigid body. Translation is a motion of rigid body that preserves its orientation in space constant. For example, the motion of a cabin of this big wheel is translation. It's curvilinear translation as it's moving along the circle. The simplest type of translation is rectilinear translation along the straight line. For example, this amusement shows rectilinear translation along the vertical axis Z. A needle of sewing machine also translates along the vertical axis, and the fabric of this example translates along the horizontal axis. The rack of these rack and pinion mechanisms shows a rectilinear translation. Let's start with the definition of translation. Translation occurs if every line segment of the body remains parallel to its original direction at initial instant. For any points A and B, the segment AB is always parallel to itself and is always parallel to its initial position A0, B0. The properties of translation are following. Firstly, trajectories of all points of translating rigid body are the same. For any points A and B, trajectory of the point A is the same as trajectory of the point B. Secondly, the velocities and accelerations of all points of translating rigid body are equal. For any points A and B, the vector of velocity of point A is equal to the vector of velocity of point B. Similarly, the acceleration of point A is equal to acceleration of point B. All points of rigid body in translation move in the same manner. Hence, it's no need to observe each point of translating rigid body. It is absolutely sufficient to observe only one point. This statement allows to make a very important conclusion. Rigid body that undergoes translation can be described by a more simple model, a particle. Rigid body in translation has 3 degrees of freedom. They are 3 rectilinear translations along axes X, Y, and Z. So, we need to specify 3 generalized coordinates. They are Cartesian coordinates XA, YA, and ZA of some point A, which is usually called as the pole. Law of motion consists of 3 equations of motion. XA is function of time t, ya is also function of time t, and za is also function of time t. They are the functions connecting coordinates of chosen point A and time t. Kinematical characteristics of the rigid body in translation as a whole are: firstly, the velocity of rigid body v, which is equal to the velocity of the pole A, and secondly, the acceleration of rigid body A, which is equal to the acceleration of the pole A. These two vectors, the velocity of rigid body and the acceleration of rigid body, can be shown from any point of this body. Velocity and acceleration of arbitrary point can be found as following. For any point M, the velocity Vm is equal to the velocity of a rigid body v and is equal to the velocity of the pole A. Similarly, the acceleration of the point M is equal to the acceleration of the rigid body A and the acceleration of the pole A, as all points of rigid body in translation move in the same way. Let's summarize all these facts. Translation occurs if every line segment of the body always remains parallel to its original direction at instant t0. Properties for all points trajectories are the same, and velocities and accelerations are equal. A rigid body that undergoes translation can be described by a more simple model, a particle. Translating a rigid body has 3 degrees of freedom, 3 rectilinear translation along axes x, y, and z, and its position can be described by means of 3 generalized coordinates. They are Cartesian coordinates of the pole A, xa, ya, and za. The law of motion consists of 3 equations of motion which look like functions connecting coordinates of the point A and time t. Kinematical characteristics for the rigid body as a whole are the velocity of rigid body v, which is equal to the velocity of the pole A, and the acceleration of rigid body A, which is equal to the acceleration of the pole A. Velocity and acceleration of arbitrary point. For any point M, the velocity is equal to the velocity of the rigid body, and the acceleration of the point M is equal to the acceleration of the rigid body.